All right, so problem number 6 says, what is the sign of delta S, or entropy, for the following reactions? So we're just going to be comparing one side of the reaction to the other to see how the entropy changes, okay? So here's your reactions, A, B, and C. So for each one, I'm always going to start and just write an arrow, okay? Now, we're going to compare the phases on each side, the number of phases. We always start with the gas, go to the liquid and aqueous, and then to the solid, okay? So over here, we've got aqueous, liquid, gas. So gas is the highest, so we're going to count that, and we look in front of it. There's only one, so I would say one gas. Over here, I have 0 gases. So if we're looking at a number line from 0 to 1, I would say it's going in a positive direction, okay? So this has a positive delta S, okay? This one, I've got gas, solid, liquid. So I'm going to go with my gases. I have one of these, 2 gases, 2, 0 gases, okay? So if I'm going from a number line from a 2 to a 0, I'm actually going negative direction, right? So that's a negative entropy. Last one, gas and gas, gas and gas. Okay, so now we're actually comparing the amounts. I have a 1 here, sitting here, and a 3 here. So 1 plus 3 is 4 gases. And over here I've got a 1 and a 1. So that's 2. So if I go from 4 to a 2, I know I'm going to get a negative number, so that's a negative entropy, or delta S, okay? So these problems should be pretty simple. Just start with your arrow, and you're just comparing both sides, okay? All right. All right, number 7 says, what is the delta S, or entropy, of the following reaction? And then they give you this chemical reaction, okay? So when I'm finding the delta S, it's the same thing as when we use Hess's law, products minus the reactants, with one exception. Your elements in their correct form don't equal 0, okay? All right, so we set it up exactly the same way. Delta H is going to equal the product side minus the reactant side. So right here, I've got 1 mole of that. And instead of using my delta H table, we're looking for delta S, standard absolute entropies right here. So I'm going to find this on my list, okay? If I look for it, I will see that it equals 76.1. And now your unit is joules per moles Kelvin. So it's a little bit different. So the process is the same. Okay, that's all I have here. So I'm going to subtract. Now I'm going over here. I've got 1 mole of this, 1 mole times, and if I look for liquid H2O on my list, I get 69.9 joules per moles Kelvin. And last, oops, here's my plus, I've got 1 mole of this, and if I look for this on my table, it is 38.2 joules per moles Kelvin. Okay, so your moles are going to cancel. I'm going to take this, multiply this, I'm going to subtract from each other, and I'm going to look at my placement. So it looks like every single one of these goes out to the 10th spot, so that's where my answer is going to go out to. So I have a negative 32.0, because I got to go to the 10th spot, and my unit is joules over kelvins. Okay, so joule kelvins. So this should be the answer to number 7. Let's look at number 8. It says, if the delta H, or enthalpy, of a reaction is negative 1023 kilojoules per mole, and the entropy is negative 324 joules per mole Kelvin, what is the temperature range for which this is spontaneous? Okay, so I know that it's spontaneous as long as that answer is less than 0. So we're going to be using, we can't use Gibbs free, can we? Let's see. Nope, they want to know the temperature range. So we're going to set it up like this. Delta H minus T times delta S is less than 0. So this side has to be less than 0 in order for it to be spontaneous. So they gave us some of that info. They gave us the delta H. They said it was negative 1023 kilojoules per mole. So I'm really just plugging things in. Minus, now we're looking to see what temperature this is spontaneous at, so that's what we're solving for. And then they gave us delta S, which was negative 324 kilojoules per moles Kelvin. And remember, it's got to be less than 0. So we're basically just going to be solving this with algebra the rest of the way. We're going to solve for T. So go ahead and we're going to add this to the other side, okay? So now I've got 23 kilojoules per mole over here. And the rest of this is still sitting here. Kilojoules per moles Kelvin. Okay, my next step, I realize a negative times a negative is going to be a positive. And I'm going to, in order to undo the temperature, I'm going to divide by 324 kilojoules per mole Kelvin. Okay? If I do it there, I have to do it on the other side. This cancels. So now I'm left with T is less than, and if I crunch this, before I do that, I'm going to cancel my units. Kilojoules cancels, moles cancels. I'm left with a Kelvin, which is good. That's a temperature unit. So I divide these two, and I end up with 3.16 Kelvin. Okay? So really, they just want to know at what temperature here is this whole side less than 0 at this point. So from 3.16 Kelvin, it has to be less than that. Okay? All right, so let's look at number 9. Okay, number 9. It says determine the activation energy and delta H for the following reaction, and then they ask if it's endothermic or exothermic. So here's a rough sketch of what it looks like, okay? So they want you to find the activation energy and the delta H. So first, let's go ahead and find delta H, okay? Delta H is just simply the products minus the reactants. So if I look over here, this is my product side. So I'm going to follow it over, and I've got 1,200 kilojoules. Now I just need to subtract my reactant side, which is down here, which is 200 kilojoules. So it looks like my delta H, if I do this, is 1,000 kilojoules. Okay? That's your delta H. Now they want activation energy. So really they're asking when it starts, when the reaction starts, to the peak of it. They want to know what is this difference here. So I'm going to say, okay, the activation energy at the top is 1,500, and I'm going to subtract where it was down here, which was 200. So if I do that, I'm going to end up with 1,300 kilojoules for the activation energy. That's how much energy it took. All right, the last thing they ask is this endothermic or exothermic? So I look to see what sign is in front of this. There's nothing there, so that's positive. Positive is always on, if I have my equation here, positive is always on this side, which means it is endothermic. So that's an endothermic reaction. All right, last one to look at is number 10.